So for problem number 14, these were very similar to the questions that were asked in our PVC whistle lab, and just looking at the harmonics. Remember, these are the tones that are multiples of the first fundamental frequency that create those really clear, high, pleasing sounds, right? So I already filled in the drawings here to make our lives a little bit easier and the video flow a little bit better. Some common mistakes here were people skipping around to sort of the wrong harmonics on the pipe open at one end. Some people drew in the first and the second one with a note at the end and correctly identified that there wouldn't be one, but what I was looking for here was the ones that make the tones. So you weren't like technically wrong. It just wasn't quite what the question was asking for, and I might be what I talked about when I lectured was that they're essentially, for the second harmonic for the open end, we skip that one. So let me just give you a sense for what I was looking for here. And these were two separate cases. So the quantities given, the thing that was the same here was the 340 meters per second. The cases were different in terms of the frequencies and the wavelengths for both. And I was expecting you to find them. And I wanted you to show at least some work. If you didn't show any or you showed very little, you lost some points. But if you showed some basic framework for how you approached it, I gave you full credit for that. So we're going to use that handy dandy V equals F lambda formula that never lets us down, okay? So in this case, when we're calculating the wavelength here, if I solve for it over here, we know that the wavelength equals V over F. In this case on the right, I'm going to be looking for the frequency. So what I'm going to do is I'm going to set it up again, V equals F lambda, and I'm going to divide both sides by lambda. So I'm going to get the frequency equals the speed divided by the wavelength. And that will allow me to solve for this column, and this one will allow me to solve for this column. Okay, so the wavelength here, we've been given the frequency and we know the speed. And I had one student, I don't remember who it was, who actually wrote out the speed over here on either side. Keep in mind that your speed has two significant figures. And then the 440 here has two significant figures, and your 2.0 here also has two significant figures. So we're never really deviating from two sig figs. So for here, I'm going to plug in 340 meters per second divided by 440 hertz, which gives me, with two significant figures, 0.77 meters. So that would be your wavelength, okay? Because I'm going directly from the first, cleanly to the second harmonic, cleanly to the third. Essentially, I'm not skipping. Sorry, I'm having some tech issues, and this has happened like a few times, so give me one moment. You won't notice it too bad. I can pause my recording, So for the situation with a guitar string, we don't skip any harmonics, so we don't skip any basic shapes. So our frequency doubles because we've now added two portions of the original. If you remember, the first case here is half of a wave. So now we've got two halves of a wave. So we have one full wave. That means we doubled our frequency. We crammed 2 times the number of waves into this space. So my frequency doubles up to 880 hertz. Okay, and I just use the same approach here by saying that lambda equals 340 meters per second over 880 hertz, right? So with all sig figs in mind, that is 0.37 meters. So that's the wavelength, okay? Same thing, next case, you have 3 versions of the fundamental shape or the fundamental wave. So you have 440 times 3, which is 1320 hertz. And we do the same approach here. As long as you showed your work for one of them, I was kind of okay if you didn't show the work to the depth that I am. I would encourage it just in a general sense because it's good for keeping track of things. What this ends up becoming is 0.26 meters. Okay, so here are your answers for the first case. Now, the second case changes, so we're not dealing with the same fundamental frequency. A lot of people were trying to write 440 here. This wasn't the case. You were actually able to find it because you still knew that it was 340 meters per second for the speed, and we know that F equals V over lambda because we solved for it down here. So we're going to say that that equals 340 meters per second divided by the wavelength, which was 2.0 meters because it was given right there. So we know that our frequency is equal to 170 hertz with two significant figures, okay? Okay, so here's where it gets tricky. So if we do just a simple doubling of the fundamental frequency, we're going to get a node at the open end. So we have to triple it. So our next frequency up is 170 times 3, which is 510 hertz. Okay, now we have to go the other way around. We know that this frequency is 510. So I'm going to use the formula from the left side and say that the wavelength is 340 meters per second divided by 510 hertz. And then I'm going to get that the wavelength here is 0.67 meters. Circle that up, circle that up, circle that up. Same thing up here. If we were just add another 170 to this 510, we would get a node at the open end. So we have to go up one more. So we do 170 times 3, which gives us 850 hertz. Okay. And then we do the same approach here with lambda equals 340 meters per second divided by 850 hertz, which gives us a wavelength of 0.40 meters. Okay, so there are your answers with significant figures, and those are the ones that we approached. So the trick here was, a lot of you understood the idea that we skipped the second harmonics, but this is the way we write it out. We don't even write the second case down if we're drawing it out in an official setting like this. Okay, so keep that in mind. Like, we don't even write out those cases with nodes at the open end. We just skip right over them. Okay. I will see each and every one of you next week. Feel free to email me during class today if you have questions. I'm around. Just at my house. So let me know. I'm going to write down my cell phone number here. Most of you have it already. Feel free to give me a call during class if you have any questions or need any clarifying things answered. If you did not get your test, I'm checking in on that. I had a TA put them in the mailboxes, so I'm checking in with them to see if maybe they misplaced one or two of them. So if you don't have your test, don't worry. It still exists. I did not just like feed it to my dog, but I'm tracking it down. If you don't have it with you today, please work on a separate piece of paper and just work through all the problems like just on that paper. If you have your test, please, at the end of class, I'm grading these. So I want to make sure you did this stuff today. Take a picture of the first page of your test and put that in OneNote. The details for that are in the email. It's in your handout section, and I think it's called test review. Please put a photo of the first page of your test. Okay, I'm grading you for that. That is a grade. Okay, see you guys later.